Thanks. Hello, everybody. Welcome to this talk with the title Disintegrated Telemetry, the Pain of Monitoring Asynchronous Workflows. My name is Johannes. I'm a software engineer at Grafana Labs, and I'm working on a team whose mission it is to make Grafana users successful with OpenTelemetry instrumentation. As part of this work, I'm also involved in the upstream OpenTelemetry project. I started out some years ago contributing to the OpenTelemetry C++ SDK. In the meantime, I'm a maintainer for OpenTelemetry semantic conventions, and I'm participating in a work group that works on messaging semantic conventions. And it's the work in this group that also prompted me to give this talk. I will not give you any fun facts about me because I'm here to talk about pain. And we start out by deconstructing the title of this talk because it's quite dense, and by defining the terms that we are using here. We start with asynchronous workflows. So in the context of this talk, we define an asynchronous workflow as a workflow that involves asynchronous communication between different services. The latter part is quite important because asynchronous communication can also happen inside a single service, inside a single process, but that's not what we're focusing on here. We will focus on asynchronous communication between different services. Disintegration is commonly defined as the process of losing cohesion or strength. It's basically the process of a thing falling apart. Telemetry and monitoring I put into the same bucket here. I will not give an exact definition, but I will narrow down what I will talk about. And in this talk, I will almost exclusively focus on distributed tracing. Why? Because distributed tracing is a really promising tool when it comes to monitoring asynchronous workflow, because it promises us to get a complete overview of our workflow. However, experience shows that distributed tracing is also the tool that causes the most pain when it comes to monitoring asynchronous workflows. Which, last but not least, leads us to pain. We have a simplified definition here. We define pain as an unpleasant sensory and emotional experience. And we will see how that experience can come about when we define the other three concepts here. So let's start going a bit deeper, and let's talk about asynchronous workflows. I will do that by using an example, and I apologize. This cartoon here, it's neither well drawn, nor is it funny, nor is it interesting, but it models an asynchronous workflow, so that's why we're using it here. What do we see here? We see somebody pushing their bike to a bike mechanic and saying, I need my bike fixed. The bike mechanic says, sure, I will text you once I'm done. The next day, the owner of the bike receives a text message. Great, the bike is fixed. I'll go pick it up right away. He picks up his bike and pays for the service. As I said, nothing exciting here. Let's try to visualize this workflow that we see here. And we get something like this here. We have like a Gantt chart-like visualization on a time axis. The black bars denote actions done by the owner of the bike. The gray bars are actions done by the bike mechanic. And we see the owner requests a fix for his bike. The bike mechanic accepts the bike. Then we have a long period of time where nothing happens. After that, at some point, the bike mechanic fixes the bike, sends a message. Again, we have a smaller time period where nothing happens. And finally, the owner of the bike receives the message, picks up the bike, and a payment is processed. This, I think, somehow reminds us of a distributed trace already, but not quite. It doesn't look like the distributed traces we see in textbooks. Why? Firstly, we don't have this root span that covers the whole duration of this trace. And then secondly, we have these awkward gaps that kind of tear apart our trace, and we end up with those clusters or chunks of spans that we have here. We kind of see that this trace kind of disintegrates, which leads us to disintegration. Let's try to understand how this comes about. What's the cause for this? We see here two pairs of tasks or operations connected via a dotted line, and each of those pairs, those two connected tasks, those are tasks that are logically connected. So this means that a bike can only be fixed when it was accepted before, and a message can only be received when it was sent before. So we have a logical connection here. However, those tasks are temporally decoupled. Quite a fancy term. What does it mean? It means that there is no temporal overlap between those two tasks. The latter one can happen any time after the first one, and we don't have any boundaries of when that is. So we have tasks, again, that are logically connected but temporally decoupled, and this is how these gaps here come about. Temporal decoupling, it's not a bug, it's a feature, and it's a very important feature of asynchronous workflows. It's actually a reason why many people use asynchronous workflows when designing their systems. Why? Because thanks to temporal decoupling, producers and consumers in our workflow aren't restricted by each other's availability. They don't have to run concurrently, and this in turn allows us to increase the reliability and resilience of our workflows. Just to give a real-world example here, communication over Slack is asynchronous communication. And just for a second, imagine that instead of writing messages over Slack, you would need to use synchronous communication. You would need to call people. You would need to get in a room to have a meeting. It would be awful. It would be very inefficient. And thanks to synchronous communication, also via Slack, communication goes much smoother, much more reliable, much more resilience. And we see the same when designing our systems and designing our workflows. So, to summarize, temporal decoupling causes disintegration. However, it's a feature, it's not a bug. As long as we don't put monitoring and telemetry into the picture. So let's throw that into the mix and let's ask, how now should we model such workflows as distributed traces? How do we go about that? We have an obvious option here, pretty similar to what we saw before. We just put everything into a single trace. As I said, it's not our textbook trace. We don't have a real root span here. We have these awkward gaps, but you know, temporal decoupling, we understand that. It's fine. Now let's try to increase the complexity a bit. Let's scale out, and let's say we have a very talented bike mechanic who can fix 3 bikes at once. We see this here. 3 bikes are fixed, 3 messages are sent, are received, 3 bikes are picked up. I'm not sure how you feel, but for me, that looks quite confusing here. It's hard for me to see the actual logical connection. The spans are all over the map. And furthermore, we don't have our whole workflow modeled here. We don't see our accept fixes, accept bike spans, and our request for fixing the bike spans anymore. Why? Because those start out as 3 separate operations, 3 separate requests, 3 separate traces that don't know about each other. Each starts with a different trace ID, and we cannot fan this into a single trace later on. So we can actually not model the whole workflow in a single trace here. At this point, let's dive a bit into the theory behind distributed tracing. Let's look at some also darker corners of distributed tracing, and let's see what ways we have to correlate spans. And we basically have 2 ways. The first one is via parent-child relationships. A parent-child relationship is a 1 to n relationship. This means every span can only have one parent, but every parent can have n children. And parent-child relationship, that's also what constitutes a trace. So inside a single trace, all the spans are directly or indirectly related via parent-child relationships. The second way we have to correlate spans is via span links. Span links are an end-to-end relationship, which means any span can have any number of links, and any span it links to can have any number of other links. Also, with span links, one can connect or correlate spans that are part of different traces. So let's try to use span links, and let's see how can we model our workflow by using span links. And we see one possibility here. We have the same workflow as before. However, it's not in a single trace anymore. We split it up in 3 different traces, and we connect these traces together via span links. And there's 2 interesting things we see here. First, we see that now every single trace models a synchronous chunk of our workflow. So every single trace now is closer to the traces that we see in distributed tracing textbooks. And we also see that our logically connected but temporally decoupled spans are connected together via span links, and that's what ties those 3 traces together. Doesn't look that bad. How does it scale? Again, let's think about our talented bike mechanic who can fix 3 bikes at once. And we actually see 7 traces here now that are correlated. We see 3 traces where a request for fixing the bike is made, and then those traces all fan into this fix 3 bikes operation. 3 messages are sent, and then again we have 3 traces where this message is received and the bike is picked up. Looks a bit, or quite a bit I have to say, better to me. I kind of, on one glance, one understands what's going on. It's a nice modeling with span links. However, not everybody likes this. Why? Because usually we just are accustomed to see a trace as an isolated thing. We have this trace and we look at it in isolation. And here we have not a single trace anymore in isolation. We have a set of traces that are interconnected. And this is a much more complicated graph problem to solve. That's why we see wildly varying different support for span links across tools and vendors. It's hard. It's a hard problem to solve. Also, when it comes to sampling, we don't yet have a good sampling solution that takes span links into account. Again, it's a hard problem to solve. But it looks pretty cool when we look at it like this. And one more note, it's kind of a meme floating around that we say, oh, span, it's nothing more than a fancy log. But I would slightly disagree, and when we see what we can build out of spans, I would say actually a span is a very fancy log. So I think we are ready to talk about pain now. Let's imagine somebody who has to monitor the synchronous workflow and needs to instrument this workflow. How should that person go about? And we come across several pain points here. The first on the list, there is no established best practice out there for instrumenting such workflows. There's different opinions. Some do it like this way, some do it that way. Some use span links, others don't. We saw 2 different options just here, but there is no established best practice. So people are confused when they start out. There's the option to do it as a single trace, but there we saw that things get large and confusing for complex workflows. Also, some scenarios are impossible to model as a single trace. We can use multiple traces, span links, but that might be an overkill for simple workflows. We talked about the different levels of support for that from tools and vendors, and it breaks sampling. Finally, we could try to adopt some scenario-specific solutions. We say, okay, sometimes we use single trace, sometimes we use multiple traces, whatever fits best. However, here we have the problem of a lack of consistency because usually we benefit from tools and vendors giving us like curated experiences for certain instrumentation scenarios, and when there's no consistency, that doesn't really work. Also, there are scalability challenges because most workflows start out simple. We can perfectly model that as a single trace. However, as the workflows mature, get more complex, we might need to rethink that, re-instrument, and we break our observability workflows. We see the pain here, we see the confusion. Is anybody working on making this better? Is anybody working on reducing the pain we have here? Yes. There is something out there called open telemetry semantic conventions. Maybe some of you have heard about those. They're becoming kind of infamous. And they cover not just traces, they cover all telemetry signals, but for traces, what do we get from semantic conventions? Semantic conventions give us standardized span names, attribute names, and span relationships for certain areas, for certain instrumentation scenarios. There's also a messaging work group working on semantic conventions for messaging. I'm part of this work group, and it's our goal to provide stable semantic conventions for messaging traces and metrics this year. And in this group, we discussed this problem that we saw before at length, actually for more than a year. We discussed and debated, and here's the solution that we came up with. So if you instrument an asynchronous workflow and you do it conforming to semantic conventions, that's what you have to do. You need to have a span of type producer for the operation that publishes the message. You need a span of type consumer for the operation that receives or consumes this message. And you need a span link that connects those two spans together. What does this give us? Well, whenever we see this pattern, producer span, consumer span, span link, then we immediately know, okay, this span link, this models an asynchronous communication channel. We also can make sense of this gap between the producer and the consumer span, because this gap gives us the time that this message spent in queue, which is quite an important metric in the messaging world. However, what semantic conventions don't prescribe is whether you put all this into a single trace or whether you model this using multiple traces. You can put this into a single trace, then you have a span link inside one trace. You can also split this up and model this with separate traces. Then you have a span link that connects two traces together. What do we gain from this? Well, what we have now here is we have an invariant. We have this span link that is consistent across all scenarios. But on top of this invariant, we have lots of freedom and of flexibility of how we structure our traces. Let's see how this addresses our initial pain points. We flatten out this list and let's go through point by point. No established best practice. I didn't mark this green yet because, yes, we have this as part of semantic conventions. We have this written down, but it's not stable yet. It's still in an experimental standard. We want to stabilize it this year. And if it's stable, I would put a green check mark there, but we are not 100% there. Large and confusing traces for complex scenarios, not really. We have the option now to split our traces up. Impossible to model certain workflows? No, we can model fan-in scenarios as we saw with span links. Varying levels of support from tools and vendors, that's a problem that we still have, and it is a bit of a chicken and egg problem. There is No good support for span links because they are not used much, and they are not used much because there is no good support for it out there. However, during the last 1-2 years, we saw a quite dramatic improvement in the ways how vendors support span links. 2 years ago, there were lots of vendors who didn't support span links at all. Today, almost all vendors have some kind of support for span links, so the situation is improving. And we also think that those using span links in semantic conventions can act as a catalyst for also bringing vendors to implement better support for it. Overkill for simple workflows, not really. We still can put everything in a single trace for our simpler workflows. Breaks established sampling solutions, yes. This is a problem that's not solved yet. I didn't mark it as fully red because I think it's not a problem that's impossible to solve, but it's not resolved up to now. There is an open telemetry sampling SIG, a bunch of smart people sitting together and coming up with sampling solutions, and they are aware of this problem. They have it on the roadmap, and we from the messaging work group, we want to work together with them to come up with a good solution for sampling link traces. Lack of consistency, not really. We have our invariant now, this link that is the same across all our modeling scenarios. And scalability challenges, those will always be there, but we benefit from our flexibility now here because we can start out modeling our simple workflows with a single trace. And as the workflow matures, get more complicated, we can switch to modeling this with multiple traces without breaking our invariant that we have. And that works as long as we build our observability workflows based upon this invariant. So where are we standing now? Is the pain gone? Is the pain resolved? Is the situation better? And I'm sad to say, not really for the practitioner out there. I think we have a solution here. We have this vision. We know in what direction we need to head. But if somebody would come to me and ask, I have this asynchronous workflow, how should I model this today? How should I instrument this? If I would be brutally honest, I would need to give an answer like this. I would need to say, yes, there is a solution, we came up with a solution, but the standard it's written down in is not stable yet, so maybe things might break, I don't know. There exist very few instrumentation libraries out there that implement this standard, this semantic convention, so depending on what technology you're using, what language you're using, you might end up with the need to write this instrumentation yourself, to maintain it yourself. I hope that's not a problem for you. Context propagation standards aren't stable yet. So you somehow need to pass context from the producer side to the consumer side. However, there's no stable standard for context propagation for messaging protocols up to date. So just pray that injecting and extracting context on both sides is consistent in your case. Also, it breaks existing sampling solutions in most cases. So just take some money in your hand and sample 100% of your traces. And even then, you end up with likely very different experiences depending on what tool and vendor you're using. So, as I said, we have a solution. We know in which direction we need to head to. We are trying to go in that direction, but we are by far not there yet. So there is lots of work to be done. Instrumentation standard, we are currently working on that. As I said, we want to stabilize semantic conventions for messaging this year, and we are on a good way to do so. After that's done, we want to focus on providing instrumentation libraries implemented on those semantic conventions, so not everybody needs to write their instrumentation themselves. Context propagation is a big area of work. We actually have something there already. there is first public working drafts of W3C trace context for AMQP and MQTT, which are the two most popular messaging protocols out there. There's also something in the cloud event specification about context propagation. However, all of those are not actively worked on currently, they are not stable, and they are practically not used at all. So this area needs some love to adopt those somebody to adopt those standards, to work on them, to push them forward, to work on adoption for them. And also our work group wants to take that up once we are that far in the list. Sampling, big question mark. But as I said, there is the OpenTelemetry sampling SIG. They are aware of this problem, and we want to collaborate with them to come up with a good solution for sampling linked traces. And last but not least, vendor support for span links. As I told you, we have very different levels of support there across vendors. However, we saw improvement over the last years, and as we work through this list, as adoption for span links increases, we expect that also the support on vendor side for span link gets better and more consistent. So lots of work to be done. If you are itching now to help us, get in touch with us. Also, if you think that's a great solution, tell us. Even more important, when you think that's a really bad solution, it really sucks, it will never work, also come and tell us. You can reach me, of course, here in person. You can hit me up on the Monitorama Slack. There's the channel for this talk. Also, CNCF Slack is our standard way of communicating for the messaging work group. So we have this OTel messaging group there. You can also ping me there directly. Our work group meets each week on Thursday, 8 a.m. Pacific time. So tomorrow morning, we're meeting again. We are always happy about anybody who shows up there, who tells us about their experiences, about their pains, because that helps us a lot to validate the solutions that we try to come up with. And last but not least, you can always send us a GitHub issue in the Semantic Convention repository. That said, thanks for bearing with me here after 3 probably exhausting days for you. Thanks for going together with me through those cycles of disintegration and pain.
All right, we've got time for maybe 1 or 2 questions. Any questions here? One right down.
Sorry, maybe my experience is not enough. Why do we need tracing for this case? It sounds for me as like event-based monitoring. Why not follow by status? Broken, fix it, I take it back.
I guess, why do you tracing for this scenario?
Why do you use tracing scenario? Because with tracing, you can correlate the producers and the consumers. You can see.
More context to event. That's all.
Well, that works for simple scenarios, but when you have like a system of like hundreds of services that communicate on an event-based basis, things get quite complicated. And of course, you can add context to the event, but you have to do this in a standardized way that works for like a wide variety of scenarios. And in the end, of course, you could try to do that, but it's likely that in the end, you just come up maybe with distributed tracing v2 for that scenario.
Although if you do, submit a talk for next year's Monitorama, because everyone here will love to hear it.
We'll be happy to see a real use case when we need distributed tracing for a thing like such a single functionality. I cannot imagine it, but really we'll be happy to hear, to see such.
Yes, I mean, we have many use cases, for example, where people say, okay, I have most of my system instrumented, but I have somehow Kafka here in between, and that just breaks everything. I have like this side and I have that side, I have Kafka in between, and I cannot really make the connection here. We have those use cases definitely out there. But I would love if you would show up into maybe our meeting and we could discuss. We are always happy to be challenged with what they come up with.
All right. I think, yeah, go ahead.
Maybe not a good question, but could you elaborate a bit more on the difference between the new standard and the previous solution using lengths? Like both of them using lengths? distributed.
What's the difference between the two standards?
You mean the two solutions, like the single trace solution and the multi-trace solution? Is that what you're?
So the difference is that the previous module trace increases and the new standard has
I mean, when we talk about the previous standard, I think the problem there is that there is none. There is no previous standard, so it's just like a bit like the Wild West out there. People like who are instrumenting their asynchronous workflows, their messaging workflows, they do it in wildly different ways now. So there is not really any standard out there. And that, as I said, causes pain for many users.
I think there's one right here, yeah.
What do you think about how you would model cases when the consumer attempts and fails the work and it gets retried maybe a couple times and then succeeds?
Yeah, how do you model when things kind of intermittently fail and then get better?
Well, that's a case where you just would model that like you would model that also for synchronous distributed tracing scenarios. You would just have maybe like, if you model it with different traces, you would just have several traces, and the first two of them will fail, and then one will succeed for this given message. When you put it in a single trace, it's similar. You just then have your spans that process the message that fail, and then a retry attempt kind of will succeed. And here, I mean, you can reuse what distributed traces gives you here in kind of the error analysis capabilities.
Great, let's give it up for Johannes.